There's this single line running for over 800 miles right underneath California. It's one of the most famous, or maybe infamous, geological features on the entire planet, the San Andreas Fault. And today, we're going to dig into a huge question. What would actually happen if all that pressure that's been building up for centuries was released, all at once? All right, let's just start with a really dramatic thought experiment. What if you woke up one morning, turned on the news, and California had literally split in two? I mean, it sounds like the plot of some crazy disaster movie, right? But asking this question, even if it's a bit over the top, really forces us to look at the real, fragile systems that hold a modern state like California together. Okay, so let's get one thing straight right away. Geologists will tell you that a clean, neat split, like you see in the movies where a giant chasm opens up, that's not really how it works. It's not scientifically realistic. But, and this is a huge but, the real consequences of a major rupture along that fault, they would be just as profound. We're talking about a catastrophic chain reaction that would completely reshape the state as we know it.
All right, first up, the restless fault line. Because, to really get a handle on the risk, we have to understand what's actually happening, geologically speaking, right under everyone's feet in California.
So the San Andreas Fault isn't just some crack in the ground. It's what scientists call a transform fault. And what that really means is it's the massive, sprawling boundary line where two of Earth's tectonic plates, the Pacific Plate and the North American Plate, are constantly sliding and grinding past one another. So just picture that. California is literally built on the meeting point of two colossal, always moving pieces of the Earth's crust. And yeah, this is not a static situation. These plates are always moving. The Pacific Plate is creeping northwest at about 48 millimeters a year. Now, to put that in perspective, that's roughly the same speed your fingernails grow. It doesn't sound like much, right? But when you stretch that out over decades and centuries, that tiny, steady movement builds up an absolutely incredible amount of stress. And eventually, all that stress, it has to go somewhere.
And we have absolutely seen this pressure release before. I mean, the fault has a long, well-documented history of major quakes. You've got the massive Fort Tejon earthquake back in 1857, the infamous San Francisco quake of 1906 that everyone knows about, and more recently the Loma Prieta earthquake in 1989, which a lot of people still remember very clearly. This timeline makes one thing crystal clear. Big earthquakes here aren't a question of if, they're a question of when.
Okay, so this leads us right into our next big topic, the infrastructure domino effect. Because this is really about how one single event can trigger a total systemic failure. So how does that geology we just talked about turn into a full-blown modern crisis? Well, a major rupture isn't a single isolated thing. Nope. It's the first domino that falls, triggering a cascade of failures across all the interconnected systems that our society completely depends on.
I mean, just think about the lifelines of any modern state. You're talking about water, power, the internet, highways and railways, gas pipelines, the whole shebang. And in California, every single one of these critical systems has to cross the San Andreas Fault somewhere. That makes them all uniquely vulnerable to being cut, severed, broken, all at the exact same moment.
So let's trace that first domino, shall we? The ground shifts, violently. And those massive aqueducts, the ones carrying water from places like the Sierra Nevada and the Colorado River to huge coastal cities like LA and San Diego, they just snap. And in that one instant, the main water supply for literally tens of millions of people is just gone. Cut off. The chain reaction is immediate. We're talking split seconds. At the exact same time those aqueducts are breaking, the shaking and the ground literally moving would snap high-voltage power lines and shred the fiber optic cables that are the backbone of our internet. So just as the water stops flowing, the lights go out, and all communication networks just go silent. It's a total systemic shutdown. So what happens next? A global economic shock. Because when California's economy just stops, the whole world feels it. This kind of local infrastructure collapse wouldn't just stay within California's borders. Oh no. It would immediately ripple outward, triggering a massive economic shockwave that would be felt not just across the US, but all around the globe. To really get a sense of the scale here, just look at the ports. The ports of Los Angeles and Long Beach together handle about 40%, let that sink in, 40% of all container imports for the entire United States. A major earthquake would paralyze this absolutely vital artery of global trade. The flow of goods, both in and out of the country, would just stop.
And it's not just the ports either. A rupture like this would basically sever California's two very different economic engines from each other. You've got the coastal economy, that's tech, finance, global trade. It would be physically crippled. And at the exact same time, you've got the inland economy, which is the source for so much of the nation's food and water. It would be totally isolated, with its own infrastructure just devastated.
And that ripple effect? It goes global almost instantly. Suddenly, global shipping routes are thrown into complete chaos. Tech stocks would almost certainly plummet. The disruption to agriculture would make food prices spike everywhere. It would be a brutal, real-world stress test of just how interconnected our global economy really is.
Which brings us to the future. What happens after the shaking stops? This section is about recovery, resilience, and an ongoing reality. Because eventually, the focus would have to shift from immediate survival to the absolutely monumental task of rebuilding, and really just grappling with a new, permanent reality.
And it's so important to wrap our heads around the timeline for recovery here. This is not something that gets fixed in a few weeks or even a few months. The sheer scale of destruction to the core infrastructure, well, it would mean recovery would be a multi-generational project. We're talking years, maybe even decades to complete. The long-term transformations would be just profound. We would have to completely rethink how and where we build everything, our transport, our utility corridors. Urban planning would have to put seismic resilience above literally everything else. And you would almost certainly see permanent shifts in population as people and companies decide to relocate away from the areas with the highest risk.
And this really brings us to the most crucial takeaway of all. Even after a massive earthquake, even after a decades-long recovery effort, the geology doesn't stop. The plates would just continue their slow, relentless crawl, building up stress all over again for the next one. This isn't a one-time threat that you can just fix and move on from. It is the ongoing, permanent condition of living on that fault line.
And so all of this leaves us with a final, really big question. In a world that's defined by systems and forces that are just way beyond our control, how do we prepare for the inevitable? How do we build societies that can not only survive something like this, but actually recover and adapt in its aftermath?